Hey guys, welcome to CakeWalk Cambridge. I'm Aisha and you're watching Stoichiometry, but we're just going to solve one question to do a recap on the last video. This might be my shortest video ever actually, but yeah, I just felt like doing it just for like a recap. So let's get into it. So this is a past paper question. So yeah, this is exactly how you're expected to solve it. So in a titration, a student added 25 centimeter cube of 0.2 mole per dm cube aqueous sodium hydroxide to a conical flask. So what do we have from here? We have the volume of sodium hydroxide and we have the concentration. Also things to keep in mind, the volumes in centimeter cube and the denominator of the concentration is in dm cube. So you need to underline these units when you see them, because as soon as you see cm cube and dm cube, you know that you'll have to divide cm cube by 1000 to convert it to dm cube to make sure that all the calculations are uniform. Of aqueous sodium hydroxide to a conical flask. Okay, the student then added a few drops of methyl orange to the solution in the conical flask. Dilute sulfuric acid is then added from a burette to the conical flask. The volume of dilute sulfuric acid needed to neutralize the aqueous sodium hydroxide was 20 cm cube. Okay, so we need to underline this as well. And this is the reaction equation. Okay, so some things that you need to keep in mind how a titration works. So we have the burette at the top, usually filled to the 0 cm cube mark. It usually has 50 centimeter cube of the acid. And then we have the base in a conical flask with an indicator. Here it's methyl orange. And when the indicator changes color, we know that neutralization has taken place. And the volume on the burette, the final volume, the end point on the burette, will show how much of acid was needed to neutralize the amount of base that was present in the conical flask. So from here you can see that 20 centimeter cube of acid was needed to neutralize 25 centimeter cube of base. Okay, so let's get started. So the first question is, determine the concentration of dilute sulfuric acid in grams per dm cube using the following steps. So now we're going to go step by step to basically answer this main question. Okay, so we need to find the concentration of sulfuric acid in this burette. Here we've only gotten the volume. Well, we don't need to find it in mole per dm cube. We need to find it in gram per dm cube. So let's get started. So we need to calculate the moles of aqueous sodium hydroxide added to the conical flask. The first question itself gives you all the information you need. You have 25 centimeter cube and 0.2 mole per dm cube. We know that the formula for moles for a solution is moles equal to concentration into volume. So we need to multiply concentration by volume. But here the problem is that volume is in centimeter cube, concentration is in dm cube. So we'll divide 25 by 1000. And multiply that by 0.2 and you get the answer as 5 into 10 raised to minus 3 or 0.005 mole. Okay, I hope that's clear. Now the next question is calculate the number of moles of dilute sulfuric acid added from the burette. Now these questions really easy to get like confused. All you basically got to do here is understand that they've given you the equation and you need to use it. When they give you no information about the concentration of a reagent and you only have its volume, but you have the moles of another reagent in the reaction, you need to use the equation. And here you can see that the ratio of NaOH used is to H2SO4 used is 2:1. Okay, sodium hydroxide is to sulfuric acid is 2:1. We know that there are 0.005 moles of sodium hydroxide. Therefore, to find the moles of dilute sulfuric acid, all we need to do is divide it by 2 because it's a 2:1 ratio. You basically cross multiply 0.05 into 1 by 2 and you have 0.0025 moles of H2SO4. Like that, we've already finished the first two questions. Super easy. Next question. Now we need to calculate the concentration of dilute sulfuric acid in mole per dm cube. Here we already have the moles of sulfuric acid. We already know the volume is 20 centimeter cube from the question. We know that the concentration in terms of mole per dm cube is moles by volume. So all we have to do here is divide 0.025 by 20 centimeter cube. Here again it's in cm cube, so we need to divide by 1000. Therefore, concentration is equal to mole by volume. Moles is 0.0025. Volume is 20 by 1000. So you divide 0.0025 over 0.002 and you get 0.125 mole per dm cube. As easy as that. And the last question, the final part of this answer, is calculate the concentration of dilute sulfuric acid in gram per dm cube. Now this is the simplest part. What you need to know, so we already know the concentration in terms of mole per dm cube, and from the first concept that we did in moles, we know that moles for a solid is equal to experimental or given mass, used mass over the molar mass. So here we know that, here we need to know what the experimental mass is, okay, and we find out the molar mass from the periodic table. I'm telling you that the mass of sulfuric acid is 98. Okay, you can't see it, but it's actually the mass of sulfuric acid is 98. So all you have to do is convert 0.125 moles into grams. How you do that? Moles is equal to molar mass into moles. Mass is equal to molar mass into moles. So molar mass is 98, moles is 0.125 as calculated from here because it's per dm cube. We're keeping the per dm cube constant, so you don't have to do anything to that. All you have to do is multiply this value by 98 and your answer is 12.25 grams per dm cube. That's it for this video. I hope it helped you. I hope you understood it. I hope it was simple. I will be doing some more solving later. The next video will be about percentage purity and percentage yield. Again, super short video. I hope it helped you. If you have any questions, you can comment or feel free to email me at cakewalkcambridge@gmail.com. And if this video helped you, please like and share it and subscribe to my channel for more such chemistry content. I plan on doing more chem videos. Let's get through this together. See you.